Hello, welcome to a new section of this course, Testing Concurrent Applications. In this section, we will monitor a lock interface, a phaser class, an executor framework, a fork-join pool, and a stream. Then we will write effective log messages and analyze concurrent code with find bugs. At the end, we will test concurrency code with multi-threaded TC and monitoring with JConsole. Now we move on to the first video of this section that deals with monitoring a lock interface. In this video, we will learn what information you can obtain about a lock object and how to obtain that information. Testing is a common task in any software development and quality assurance process, and you can find a lot of literature about testing processes and different approaches you can apply to your developments. There are a lot of libraries as well, such as JUnit, and applications such as Apache JMeter that you can use to test your Java applications in an automated way. Testing is even more critical in concurrent application development. The fact that concurrent applications have two or more threads that share data structures and interact with each other adds more difficulty to the testing phase. The biggest problem you will face when you test concurrent applications is that the execution of threads is non-deterministic. You can't guarantee the order of the execution of threads, so it's difficult to reproduce errors. A lock interface is one of the basic mechanisms provided by the Java Concurrency API to synchronize a block of code. It allows you to define a critical section. A critical section is a block of code that accesses a shared resource and can't be executed by more than one thread at the same time. This mechanism is implemented by the lock interface and the ReentrantLock class. We start by creating a new Java project. Give it a name of your choice. I have already created one. Next, create a class named MyLock that extends the ReentrantLock class. Import the required Java libraries. After this, implement the getOwnerName method. This method returns the name of the thread that has control of a lock, if any, using the protected method of the lock class called getOwner. Now implement getThreads. This method returns a list of threads queued in a lock, using the protected method of the lock class called getQueuedThreads. Let's create a class named Task that implements the runnable interface and imports the essential Java libraries. Within this class, declare a private lock attribute named lock. Then implement a constructor of the class to initialize its attribute. Implement the run method. Here, create a loop with 5 steps. Acquire the lock using the lock method and print a message. We then put the thread to sleep for 500 milliseconds. Finally, we free the lock using the unlock method and print a message. Now let's go ahead and create the main class of the example by creating a class named main with a main method. Specify that this method throws exceptions and include these Java libraries and classes. Within the main method, create a MyLock object named lock. Then create an array of 5 thread objects. Post that, create and start 5 threads to execute 5 task objects. Similarly, create a loop with 15 steps. And here's the block of code you need to add within this for loop. Here we write the name of the owner of the lock in the console. Then we display the number and name of the threads queued for the lock. Also, we display information about the fairness and status of the lock object. Finally, we put the thread to sleep for 1 second and close the loop and the class. Let's execute the program. And here's the output which you'll see in your console window. So you can see that we implemented the MyLock class that extends the ReentrantLock class to return information that wouldn't have been available otherwise. It's protected data of the ReentrantLock class. In this video, we saw how to monitor a lock interface.